Okay, for this problem, we have this rational function, 3x cubed minus 4x plus 1 over 6x to the fourth minus 2x squared plus 7x, and we want the limit as x goes to negative infinity. All right, we're going to do this one two different ways. As we'll see, the second method will be a whole lot easier than the first method. All right, so method number one, and I'm just going to say ahead of time, this is going to be the long way, is to use L'Hopital's rule. So the limit as x goes to negative infinity of 3x cubed minus 4x plus 1 over 6x to the fourth minus 2x squared plus 7x. All right, now the form of this is infinity over infinity. If I plug in infinity, both the top and the bottom both explode. And so we take the derivative of the top and the derivative of the bottom. So the derivative of the top is going to be 9x squared minus 4. The derivative of the bottom is going to be 24x cubed minus 4x plus 7. Okay, now once again, this has the form infinity over infinity. And so we use L'Hopital's rule again. The limit as x goes to negative infinity. 18x minus 0 over, let's see, 72x squared minus 4. Okay, now once again, as x goes to negative infinity, both the top and the bottom blow up. And so we get the limit as x goes to negative infinity of 18 over 144x. Okay, now this time I do not have the form of infinity over infinity. I have 18 over infinity. So L'Hopital's rule no longer applies. As x goes to negative infinity, the bottom blows up. So 18 over a very large denominator, that goes to 0. And so the answer is indeed 0. Okay, so by repeatedly using L'Hopital's rule, and I hope I didn't make an arithmetic mistake along the way, we get the limit is equal to 0. Okay, so that's correct. Method number two, which is going to be a whole lot faster. The limit as x goes to negative infinity of 3x cubed minus 4x plus 1 over 6x to the fourth minus 2x squared plus 7x. All right, so let me rewrite the problem. Okay, so for the moment, I'm just copying. So far, nothing has changed. And the thing that's going to change is I'm going to multiply top and bottom by 1 over x cubed. Okay, so I'm multiplying by 1. I'm multiplying by the same thing on the top and the bottom. All right, now what happens? We get the limit as x goes to negative infinity of 3 minus 4 over x squared plus 1 over x cubed all over 6x minus 2 over x plus 7 over x squared. All right, now what happens to all of these terms as x goes to negative infinity? All of these terms go to 0, and so they can be ignored. The limit as x goes to negative infinity of 3 over 6x. And by the same logic as before, the numerator is constant, the denominator blows up, and so the answer is 0. And so by either method, by either just simple this algebraic manipulation, or else by using L'Hopital's rule, we get the answer of 0. Okay, so before closing the video, again, a way of double checking our work is actually drawing the graph. So the graph of the function is shown on screen, and the question is, what is the function of the behavior as x goes out to negative infinity? And as x goes to negative infinity, it looks like that this is getting closer and closer to the x-axis, which means that it looks like visually that the limit is going closer and closer to 0. And indeed, the same thing happens if x were going to positive infinity. So the answer is 0, and either by L'Hopital's rule or by algebraic manipulation, which can be confirmed by looking at the graph.